Hey everyone, in our previous session, I have discussed about linear regression model in machine learning. In today's session, we will check out another supervised learning which is logistic regression model. In this session, we will understand what is logistic regression, why we need logistic regression when we already have linear regression, how logistic regression works internally, and finally, we will write some code in Jupyter Notebook to implement logistic regression and predict some values. In the initial session of machine learning, we have realized that supervised learning are subcategorized into regression and classification. Logistic regression model comes under classification model. Though the name is logistic regression, but remember it comes within classification category. Logistic regression best suited for binary classification problem. For example, if we want to classify the emails, either it is a spam email or not, we can do so easily using logistic regression. The output of logistic regression will be either in true or false or yes or no. In case of image classification also, we can use logistic regression. For example, we will provide an image as input and our model will predict if the image is of a dog or of a cat. That can be easily predicted by logistic regression machine learning model. Remember, in this case, the dependent variable, that means the variable what we will be predicting, that particular variable will be of categorical data. In our previous session, we have discussed about linear regression where we predicted the price of a house based on the area of the house. In that case, the price of a house is a continuous value. That means it is nothing but numerical value what we have predicted. But in case of logistic regression, the dependent variables will be categorical data. For example, in case of spam email classification, the dependent variable will be either spam email or a ham email. Ham email is nothing but the emails which are not spam. That means we will categorize the emails based on some prediction. Let's understand what is the difference in the mathematical equation. In case of linear regression, we know we were establishing a linear relationship between independent variable and dependent variable. In case of linear regression, both independent variable which is x and the dependent variable which is y both were of continuous value or numeric value. In case of logistic regression, it is categorical value, and that is the reason we cannot use the same equation even for logistic regression. If we take spam email classification as an example, then the output, the predicted output will be either 0 or 1, either false or true. And to achieve that, we pass the same linear equation within a sigmoid function. Why? Because sigmoid function has a very specific characteristic. If you pass any value within sigmoid function converts it to a specific value in the range of 0 and 1. So the output of sigmoid function will have some value which is in between 0 and 1. You can pass any value. A very large value also will be converted into a specific value which lies between 0 and 1. That is the beauty of sigmoid function. And we are utilizing sigmoid function in case of logistic regression because we want categorical data as output. Here y cap will be sigma of mx plus b. Now sigmoid function is something like this: 1 by 1 plus e to the power minus mx plus b. If we take mx plus b as z, it will be 1 by 1 plus e to the power minus z. Here, if we pass a very large value of z, e to the power minus z will be 0, and 1 plus 0 is nothing but 1. Hence, y predicted value will be of 1. Similarly, if we pass a very small value of z, then e to the power minus z will be a very large value, and 1 by a very large value can be assumed as 0. So predicted y will be 0. That means if we pass any value of z, predicted y value will be between 1 and 0. Sigmoid function is nothing but this S curve. If you see here, we have a threshold which is nothing but 0.5. Now, if the value is less than 0.5, something like this, then we will move it as 0 because it comes under 0 category. If the value is more than 0.5, that means more than the threshold value, we will categorize this point as category 1. Any value above 0.5 will be in category 1. Any value less than or equal to 0.5 will be of category 0. In that way, logistic regression works. It basically evaluates the probability value of a specific category. Hope you have realized why we are passing the linear equation into a sigmoid function and why sigmoid function is very much appropriate for logistic regression model. Now, there can be a number of different sigmoid functions, but which one to choose? For that, we will have another session where we will discuss how we can choose the appropriate sigmoid function in order to perform precise prediction. Now, let's see how we can implement logistic regression with the help of sklearn library. In order to use logistic regression, first we have to import it. From sklearn.linear_model import logistic regression. Note here, logistic regression also categorized under linear_model family. Once we import logistic regression, we can instantiate a model of logistic regression. The next task is to train the model with some training data. Model.fit is a method which takes the training data as its input and train the model. We can use model.predict method in order to predict with the help of the trained model. We have score method as well, where we can pass X test and Y test, independent test value and dependent test value, check the accuracy of the model. Now, let's jump to the Jupyter notebook and write some code to implement logistic regression. In this notebook, we will implement logistic regression model to classify spam emails. To use logistic regression, we have to import it. Along with logistic regression, we are also importing few necessary packages like pandas, matplotlib in order to handle the data preparation and data visualization. Once we have imported logistic regression, we will prepare the data in order to train the model. I have a data called email_spam.csv where based on the special characters available in the email, we will predict if that email is a spam email or not. Usually in spam emails, there will be a large number of special characters. Let's see what is there within this CSV file. This dataset I have prepared for this example where we have two columns, number of special characters and is spam column. If the number of special characters are less, is spam column will be 0. That means the email is not a spam email. If there are a huge number of special characters in the email content, we will classify that email as a spam email. 1 means the email is a spam email. 0 means the email is not a spam email. In order to train the model, I have taken only initial 15 rows for my training data. Other 5 rows I have kept aside for testing the model. sklearn has some methods to perform splitting of training data and test data. In our subsequent sessions, we will check out that functionality as well. But for now, I have manually splitted the total data set into train data and test data. Here I have plotted the data points with the help of matplotlib to visualize the data points. If you see here, the x-axis is the independent variable which specifies the number of special characters present in the email content. Y-axis is the dependent variable which is nothing but is spam or not. And if you see, all my data points lies here either in 0 or in 1. In such situations, linear regression model will not work and hence we have to use logistic regression to predict the categorical dependent value. Here 0 means the emails are not spam emails, 1 means the emails are spam emails. Let's create the logistic regression model with the help of logistic regression constructor. Once we have created the model, we are ready to train the model. Here model.fit takes the training data to train the model. Let's run this. Training took a very less time because we have only 15 rows for our training data. But in enterprise solutions, training may take a lot of time based on your dataset size. Now we have a trained model ready for prediction. Let's first check what is the test data we have. If you see, the independent variable for test data has the list of number of special characters. Let's provide this as input to the model and predict the dependent variable called isPam. isPam will have categorical data. That means the data will be either 0 or 1. As we have provided metadata of 5 different emails, it is predicting for the first email where number of special characters are 4 is not a spam email. However, when the number of special characters are 31 in one email, it is predicting it as a spam email. Similarly, for 80 special characters in a single email content is also a spam email. There is a special method called predict_proba to check out the probabilities what has been calculated by the logistic regression model for our test data. If you see here, the first part is the probability of categorizing the email as not a spam email. Second value is the probability of categorizing one email to a spam email. So in the first case, 99% possibility that it is not a spam email because there are less number of special characters and hence your logistic regression is categorizing it as 0. That means not a spam email. However, in case of second one, if you see 98% probability that the email is a spam email, and that is the reason for the email where we have 31 special characters in the email content, logistic regression model has categorized it as a spam email. Hope you have understood what is the benefit of using predict_proba to understand exact probability of categorizing a test data into a specific category. In order to check the accuracy of the model, we will be using score method. Remember, score takes test data as its input. We are passing the independent variable of test data and the dependent variables of test data. Score method predict the dependent variables based on the independent variable and then it compares the predicted value with the actual dependent values we have provided. Let's see what is the score for our trained model. As you can see, the score is 1. That means it has found out the best fit S curve or the sigmoid function and predicted all the test data perfectly. Let's recap what we have learned in this session. We have realized that logistic regression model is also a kind of supervised learning model which helps us to solve the binary classification problems. In case of logistic regression, unlike linear regression, the dependent variables will be of categorical data. For example, spam email classification, image classification can be easily done with the help of logistic regression, where we will be predicting the answer in terms of yes or no, true or false, 0 or 1. In case of linear regression, we used linear equation. However, in case of logistic regression, we will be passing the linear equation into a sigmoid function, because sigmoid function always gives an output which lies between 0 and 1. Now we know how we can implement logistic regression. We have to first import logistic regression, we have to create the model, we have to train the model with training data, and then our model will be ready to predict the values. We can check the score with the help of model.score method, which takes the test data as its input. Hope you have enjoyed this session. Thanks a lot for watching this video.